Hey guys, welcome to the Max Invest YouTube channel. In today's video, we're going to be taking a look at what the Graph protocol is. Now, the Graph protocol is a very interesting crypto, and I do believe it has a lot of potential. So in this video, I'm going to be going over the basic usability of the protocol, what it actually is and what it actually does. Now, after this video, in about a day or two, I'm going to make a video going over the technical details of the graph. We'll talk about all of the specific network participants within the graph, how exactly the graph works, and how the graph maintains decentralization. Of course, if you enjoy this video, remember to like and subscribe to the channel. Follow me on Twitter, join the Discord, the links are down below in the description, and remember, nothing in this video is financial advice. So let's get into the video. Now, the first thing that we need to understand about the graph is what problem is it trying to solve. So we're first going to start by discussing the actual problem that there is. Now, there's a huge problem in the cryptocurrency space with data indexing. The graph is specifically designed to do data indexing on Ethereum. Now, what this essentially means is that we know that on the Ethereum network, there is tons and tons of code. We know that the Ethereum network stores all of its data on an immutable base layer. So as a direct result, any individual can look through the Ethereum network and all of its history and see every single transaction that's been made and all of the data that's been stored. However, it can be very difficult to sift through all of this data. So this is where we come to decentralized applications. Decentralized applications are applications that are building on top of the Ethereum network. This could be things like Uniswap, which is a decentralized exchange, LivePeer, which is a decentralized video streaming protocol, and all of the other applications that exist on top of Ethereum. So these decentralized applications need to draw from a lot of data. When they're building out their protocols, they actually need to look back through Ethereum's history and draw from a lot of different bits of data. Also, once these applications are already built out, there might be some data that they need. This data can even be about their own application. They might want to see how many people are using their application. Of course, the applications themselves may go through the code, find all of this data and collate it. However, this is very difficult to do, and the reason it's difficult to do is because there's so much data on the Ethereum network. Now, that's the problem, and this is where the graph comes in. The graph makes it very easy for these applications to actually collect the data. What the graph does is the graph is a data indexing protocol. This means that the graph essentially collects all of the data for these applications and presents it to them in a very easy to use way. All you need to look up is the graph subgraphs, and there'll be a whole bunch of different subgraphs for each different protocol that they'll all be able to use. So let's look at the ways of actually scaling data structure. Essentially, there are two technical ways to solve the data structure problem. Now, just a quick side note, this example is specifically using Uniswap pools. Essentially, a Uniswap pool is something where I deposit my assets into. If I have Ethereum and US dollars, I can deposit this into a Uniswap pool. Now, what I'm doing here is I'm providing liquidity to Uniswap, and as a direct result, whenever someone trades cryptocurrencies using Uniswap, I get paid a fee for providing liquidity into that pool. If you don't fully understand this, don't worry, you can still understand the example more or less without fully getting it. Essentially, there are two technical ways of solving this data structure problem. Now, the first one is where you would ask Go Ethereum for a list of all of the Uniswap pools. And then once you've done this, you would calculate all of the relevant transactions, calculate all of the relevant total value locked, and look through everything all yourself. Now, this is very difficult to do, and the first way is a bit unsustainable. You might also be asking, who wants to know this? Well, the first and foremost person that is going to want to know this, or group of people, is Uniswap and Uniswap developers themselves. They're going to want to know how much money is locked in their pools. They'll want to know if it's $1 billion locked in their pools or $10 billion locked in their pools, and they're going to need to look through data to do this. So That's the first way that we can actually look through data, and this is not what the graph does. In fact, the graph does the second way. Now, in this second way, it's a little bit confusing, but what the graph will do is they'll define a separate data structure, so they'll make their own subgraph for Uniswap, and every time a change happens on Uniswap, they'll add this change to the subgraph. So every single transaction that's happening is just getting added to a long list of transactions on the subgraph, and then Uniswap can just check out this subgraph and boom, all of the data is there for them. The graph shows Uniswap how much value they have locked, it shows Uniswap how much fees they're earning, it shows Uniswap how many users they have, and it shows them everything that they need, which is really good for the application, and they do need this data. So the graph makes it very easy to index data and very, very easy for protocols to use this data. So this is good for two specific things. If a decentralized application actually wants to build themselves out, they're going to need to use some of the graph's data. Also, if an existing decentralized application wants to access some information, such as Uniswap, well, they can easily do it using the graph. So this is a massive use case, and in my opinion, every single decentralized application will eventually be using the graph, building or actually getting data from the graph, and it's very important for the structure of cryptocurrencies. Now, a lot of people say that this is the Google of blockchain, and at first I didn't really understand this because I thought to myself, wait, so is the graph a search engine? But this is not the case. Essentially, whenever you search up something on Google, Google indexes all of the data for you and puts it together in an easy to understand way. So you can see all of the things at the top, see all of the articles within these certain things, and Google indexes it out. Now, Graph is doing the same thing here, where it's just indexing all of the data on top of cryptocurrencies, and the possibilities for the graph are endless. As we can see in this picture, here is all of the relevant subgraphs. Anyone can check out these subgraphs and anyone can use them, which is absolutely fantastic. Now we're going to go into some of the protocols that are actually using the graph. So as we can see, some of the graph's data consumers include Aave, which is one of the biggest decentralized applications on Ethereum, Uniswap, Synthetics, Decentraland, LivePeer, Pull Together, and all of these big applications on top of Ethereum. Now, these applications all have billions of dollars locked in them, and they're very, very large. Also, there are a lot more applications other than this. Now, an easy way to understand what the graph does is if you go onto Uniswap and then check out the stats. As you can see, I'm looking at a specific pool and I can see the total value locked is 67 million, the volume traded for this pool is 24 million, and you can actually see everything that's going on here in a really easy to understand way. And every time I look at this, it queries the graph, so it actually queries a graph subnode, and I pay some money to an indexer. Of course, Uniswap, the decentralized application, is the one that pays the graph money for its services, and it's proven very economically sustainable as we see all of these applications actually using it. Now, another case study we can check out is LivePeer. Essentially, LivePeer is a decentralized video streaming service where you can check out movies, check out videos, and all that kind of stuff on top of it. Now, when I open up the LivePeer homepage, I can see a lot of different stats. I can see how much money LivePeer is making in fees. I can see the estimated usage of LivePeer. I can see LivePeer's participation, and this is all brought to me by the graph. So the graph brings all of this forward, and this results in the graph getting hundreds of millions of queries every day. Essentially, every time a user clicks onto a decentralized application that's using the graph, this user will view its data. So let's go back to the Uniswap example. Let's say that I want to deposit some money into Uniswap. Now, what I'll do is I'll go into Uniswap, I'll click on pools, and I'll go to deposit money. Now, when I do that, what I'll be doing is I'll be querying a subgraph. So I'll be going onto Uniswap and I'll be implicitly viewing some of Uniswap's data. As a direct result, this queries a subgraph and it shows that someone has viewed the data that has been created by the graph. Now, as a direct result, Uniswap will then pay out a fee for my query. Every single time someone does this, the graph is queried, and the graph gets hundreds of millions of queries every single day. Of course, a very, very small fee is paid out every single query by the protocol. However, it is paid out nonetheless. Now, another case study I wanted to check out is cryptofees.info. If you look up cryptofees.info, you can actually see how much fee revenue all these protocols are generating. Now, on the Ethereum network, you can see that all of the protocols there are used by the graph. So the graph will tell cryptofees.info how much fee revenue all of these protocols are using. This essentially means that even centralized applications use the graph when they want data. The graph provides data to everyone. So if CoinMarketCap wants to see the total value locked in certain protocols or anything about these certain protocols, all it needs to do is use the graph, and every time someone looks at cryptofees.info, looks at Uniswap's fees, this queries the graph and money is paid to the graph. Now, whenever money is paid to the graph, it's paid to an indexer, and essentially indexers are the people that make up the graph. They're a random network of individuals that essentially bring information together, make up subgraphs, and make the graph work. However, there'll be more on indexers in the next video or so. So essentially the graph did 25 billion queries in May 2021 alone, and it's seen some massive growth. So the graph is going very, very well. There's heaps and heaps of queries and heaps of people are using it, which is good to see. Of course, 25 billion queries may seem like a lot, but if we looked at how many queries Google was having, I'd bet that it is probably 100 trillion plus every single day, some absolutely insane number. Of course, I'm just speculating, I don't really know, and I haven't specifically looked into it. Anyway, that brings us to the end of the video. If you enjoyed the video, remember to like and subscribe to the channel, and thanks for watching. Also, stay tuned for tomorrow's video on the graph, where I go into how the graph works, all of its network participants, and everything about it. Thanks for watching.